Good morning everybody. This is Dr. Sekhar Chandra, chemistry teacher. Welcome to CEI. Now today I'll continue the previous chapter, that is acid bases salts and acids, that is properties of acids. Today I'll discuss. Last class I discussed about the definition and other properties, including the preparation of acids. Today exclusively I'll teach only properties of acids, mainly mineral acids like HCl, H2SO4, etc. and H3, dilute H3. Actually, mineral acids usually, when they are in dilute condition, they act as an acid. But concentrated, they have the different properties. Like concentrated HCl acts as a reducing agent. Concentrated H2SO4 acts as an oxidizing agent. Concentrated nitric acid acts as an oxidizing agent. But in all cases, the dilute acids are acids. But concentrated, they have the different type of properties. So let me start with the properties of acids. Physical properties. Physical properties means they have sour taste. They changes different indicator like methyl orange. Methyl orange turns to pink or red. Phenolphthalein, there is no change, color change. And in case of litmus paper or litmus solution, this litmus solution turns to red in case of dilute acids. Now I repeat, they have sour in taste. Physical properties, they have sour in taste. Secondly, change of indicator, methyl orange changes to pink or red. Phenolphthalein, no change in color. And finally, litmus, that is litmus, blue litmus turns red in case of dilute acids. Now this is the physical properties of acids. Second, chemical property. Chemical property first is reaction with metals. Reaction with metals. Now dilute acids like HCl, H2SO4, they react with metals which are above hydrogen in the electrochemical series. Only those type of metals they react and to form the respective salts like chlorides, sulfates, and with the evolution of hydrogen. I repeat, dilute acids reacts with the metals which are above hydrogen in the electrochemical series to produce hydrogen gas and the respective salts. Now as for examples I can give you, that is Zn plus HCl, we get ZnCl2 plus hydrogen gas. Okay, this is dilute. Now Mg plus 2HNO3, dilute. They produce MgNO3 whole twice plus hydrogen gas. Similarly, dilute sulfuric acid, if you use dilute sulfuric acid, suppose Fe plus sulfuric acid, dilute, we get ferrous sulfate plus hydrogen gas. There are so many reactions we can show you, but calcium plus 2HCl, dilute, we get calcium chloride plus hydrogen gas. So let me conclude that dilute acids react with the metals which are present above hydrogen in the electrochemical series, produces hydrogen gas with the formation of the respective salts, means zinc chloride ZnCl2, magnesium nitrate salt, ferrous sulfate salt, calcium chloride salt, and with the evolution of hydrogen gas in all four cases or in every cases. There are some exceptions are there, like magnesium. Magnesium and manganese, they only react with dilute nitric acid to form respective nitrates and hydrogen gas. No other metals can react with the dilute nitric acid, because you know that nitric acid is a strong oxidizing agent, so hydrogen evolved will be oxidized to water, respective water. So there is exception, though there are so many metals are present above hydrogen in the electrochemical series, but only magnesium and manganese react with dilute nitric acid to evolve hydrogen gas. No other cases it is possible. In case of dilute sulfuric acid, if we see that there are some metals, though they are present above hydrogen in the electrochemical series, but they cannot continue to evolve hydrogen gas. they are calcium, they are barium, calcium, barium, strontium, lead. These 3 or 4 metals, though they are present above hydrogen, they react initially, but after some time the reaction stops because of the formation of insoluble coating of the respective sulfates. Like barium plus sulfuric acid, barium sulfates, this barium sulfate is insoluble hard crust and deposit over the barium metals, so that the reaction doesn't continue because it doesn't have any contact with the dilute sulfuric acid, so the reaction stops. Similarly, calcium, calcium sulfate, strontium, strontium sulfate, lead, lead sulfate, those sulfates are deposited over the metals to stop the reaction, so the hydrogen gas is not continue to evolve. Okay, but in case of HCl, most of the cases the reaction occurs, excepting lead, because lead, you know that lead chloride is again the insoluble hard crust, and this lead chloride is deposited over the lead, so that the reaction stops and the reaction does not occur and continue, evolution of hydrogen stops. Finally, let me conclude that dilute acids generally react with metals above hydrogen in the electrochemical series to evolve hydrogen gas with the respective metal sulfates, metal chlorides and metal nitrates. Okay, thank you. Next, reaction with the bases. Now, dilute acids react with the bases to form salt and water. And bases means, you know, metal oxides or hydroxides. So any metal oxides or metal hydroxides, they react with the dilute acids to form their salt and water. Now let me give example. Now suppose calcium oxide base plus hydrochloric acid HCl to form calcium chloride plus water. That means base, acid, salt and water. Because we know that acid plus base to form salt and water. Therefore, hydrochloric acid dilute, of course dilute, because acids only in dilute condition. Now hydrochloric acid react with the calcium oxide to form salt and water, that is calcium chloride and water. Now if I take magnesium hydroxide, this is also base, because we know the oxides and hydroxides are bases. So magnesium hydroxide is also base, react with sulfuric acid to form magnesium sulfate plus water. Similarly, FeO or Fe2O3, suppose CuO plus HNO3, 2HO3 to form CuNO3 whole twice plus H2O. And finally, one more example, let me give you. FeO plus H2SO4, FeSO4 plus H2O, and one more PbO plus 2HNO3, PbNO3 whole twice plus H2O. Now in all 4 cases or 5 cases, we find that bases react to the dilute acids, all are dilute to form their respective salt and water, because we know that acid plus base is equal to salt and water. One more thing, this lead oxide, in this case only nitric acid will be allowed to form salt and water, because other acids like HCl, if you use HCl, the reaction stops because of the formation of lead chloride over lead oxide. Similarly, sulfuric acid cannot also be used, because sulfuric acid reacts with this lead oxide to form the lead sulfate, which are deposited over the lead oxide, so that the reaction stops because there is no contact between the lead oxide and with the dilute acid, with the acids, dilute acids. So the reaction does not occur and the respective salt and water do not form. Only nitric acid is the only acids, it forms the salt and water, because we know lead nitrate highly soluble in water. So the reaction continues, so that the reaction takes place and salt and water will be formed as lead nitrate and water. Third is alkalis. We know that what is alkalis? Alkalis are soluble bases are known as alkalis. And there the examples are NaOH, KOH, calcium hydroxide, barium hydroxide, ammonium hydroxide, etc. They all are alkalis because they are highly soluble in water. So these alkalis react with the dilute acids to form salt and water. Like sulfuric acid plus NaOH, sodium sulfate, and water. Let me give or write the reactions over here. Alkalis are NaOH, KOH, NH4OH, CaOH whole twice, etc. They react with acids HCl to form NaCl plus water. They react with sulfuric acid to form K2SO4, salt and water, to KOH, plus here also you can take HNO3. If you take HNO3, then 1 mole or 1 molecule to be required. Ammonium nitrate plus water. Here we can also use 2 HCl. We get calcium chloride plus water. In all cases, we find that salt and water will be obtained by reacting with acid and bases, or here is alkali. Now NaOH reacts with acids to form salt and water. KOH reacts with sulfuric acid to form salt and water, that is K2SO4 plus water. Ammonium hydroxide, there is alkali, reacts with the dilute nitric acid to form ammonium nitrate and water, salt and water. Calcium hydroxide plus HCl to form calcium chloride and water. But in these cases, sulfuric acid cannot be used, because sulfuric acid, if you use, then we find the calcium sulfate will be deposited over the calcium hydroxide, so the reaction does not occur. So only calcium hydroxide, in case of calcium hydroxide, dilute HCl or dilute HO3 can also be reacted. But sulfuric acid cannot be used. These two can be used, but this cannot be used, because we know calcium, when calcium hydroxide reacts with sulfuric acid, it forms calcium sulfate, and this calcium sulfate will deposit over it and then reaction. But if you take calcium hydroxide solution, there is lime water. If the lime water is taken, then reaction to be continued, because we know that lime water is a soluble calcium hydroxide. It reacts with sulfuric acid to form calcium sulfate and deposited below the at the bottom of the container. So it separates from the solution. So until and unless there is any calcium hydroxide present in the solution, the reaction to be continued. But if you take calcium hydroxide solid, that is slaked lime, the reaction does not occur to continue, because over the calcium hydroxide the deposition of calcium sulfate takes place. So reaction does not occur because there is no contact with the dilute sulfuric acid and the calcium hydroxide. So slaked lime, reaction stops, but lime water, reaction to be continued, because lime water soluble and deposited at the bottom of the container, and the reaction continues. So I hope you understand. Next is reaction with the metal carbonates. Now dilute acids react with the metal carbonates to form or to evolve carbon dioxide and the respective salts. Like sodium carbonate, if you take sodium carbonate reacts with dilute sulfuric acid, it forms carbon dioxide, evolution of carbon dioxide with the formation of sodium sulfate. Similarly, any carbonates like calcium carbonate, magnesium carbonate, zinc carbonate, copper carbonate, any other nickel carbonate, those all carbonates react with the sulfuric acid, dilute, nitric acid, dilute, and hydrochloric acid dilute. They form the respective salts and water, provided there is no deposition takes place. That deposition should be insoluble. In that case, the reaction stops. Otherwise, if the salts which are soluble in water, the reaction to be continued. Now let me write one by one the examples what I have given just now. Now first let me take sodium carbonate, Na2CO3. Next I am taking magnesium carbonate. Next I am taking calcium carbonate. Next I am taking copper carbonate. Next I am taking nickel carbonate. No more. There are 5, more than enough. Now this is dilute HCl. If you take dilute HCl, we get NaCl, sodium chloride plus water plus carbon dioxide. Similarly, if you take the sulfuric acid dilute, but here you remember all should be dilute conditions. Concentrated cannot be allowed, because concentrated have a different function. CO2 plus water. Now nitric acid, if we take over here 2HNO3, we get calcium nitrate plus carbon dioxide plus water. In all cases, carbon dioxide will be evolved. Here copper carbonates plus sulfuric acid. If we take dilute sulfuric acid, we get copper sulfate plus carbon dioxide plus water. Now here we can take dilute HCl, 2HCl, we get nickel chloride NiCl2 plus CO2 plus water. Now you see sodium carbonate plus dilute HCl, if you add dilute HCl over sodium carbonate crystals or sodium carbonate solid, then we get evolution of carbon dioxide, bubbles of carbon dioxide will be evolved. Similar example, magnesium carbonate, which is a powder, this amorphous by reacting with dilute sulfuric acid, again it evolves the carbon dioxide gas. Calcium carbonate, nitric acid, the similar thing, this is a powder of calcium carbonate. If you add dilute nitric acid, then we get the carbon dioxide gas, which is evolved as a bubbles of gases with the formation of calcium nitrate. Copper carbonate is a powder, this is a green powder, this is the green powder, this green powder when comes in contact with the dilute sulfuric acid, we get green powder, blue solution, we get the blue solution with the evolution of carbon dioxide gas. Similarly, this is also light green powder, this is light green powder, we get the green solution with the evolution of carbon dioxide gas. Now let me conclude that carbonates, there are carbonates are there, and these carbonates react with the dilute acids and they react and they form carbon dioxide, which is evolved as bubbles of gases. And in case of these two colored substances or two samples I have taken, one is copper carbonate, which is green. This green powder becomes blue solution with the bubbles of gases carbon dioxide. Similarly, nickel carbonate, light green powder, forms bubbles of carbon dioxide gas with the formation of green solution. These two are color change takes place, so I am showing the color changes, but other there is no changes of color, only the amorphous powder turns to solution, colorless solution with the evolution of gas, that is bubbles of gases of carbon dioxide. Okay. Next is bicarbonates. Now reaction will be same. Bicarbonates reacts with the dilute acids to evolve carbon dioxide. Similar reactions like sodium bicarbonate. You know, sodium bicarbonate is baking soda. Baking soda, if you have in your home, in your kitchen, you can find that baking powder. If you add baking powder dilute acid, the muriatic acid, you can do the experiment in your home. That is dilute nitric acid or dilute hydrochloric acid. If you add baking powder, we will get the bubbles of gases, or that is evolution of carbon dioxide gas is formed. So, two or three examples I am showing you. Not many more is required. Baking soda is very important because it is very familiar to all of you, and it is you can see in your home everyday use. Sodium bicarbonate, that is called baking soda. This is called baking soda. You can get from your kitchen baking soda, and you know muriatic acid you can take from home muriatic acid, and if you add muriatic acid to sodium bicarbonate or baking soda powder, we'll get NaCl plus carbon dioxide plus water. You will find the evolution of gas of carbon dioxide to be formed or to be evolved. Similar examples, if you take calcium bicarbonate, HCO3, calcium bicarbonate, if you use suppose nitric acid, HNO3, we will get calcium nitrate plus carbon dioxide plus water. Evolution of carbon dioxide gas. So let me conclude. No more examples I am giving you because similar examples or similar type of reactions will take place. So I am taking only two examples. Sodium bicarbonate is very important because it is very familiar to everybody. Similarly, calcium bicarbonate, that is in this case we take dilute hydrochloric acid. In this case we take nitric acid. In both the cases we get respective salt sodium chloride and calcium nitrate with the evolution of carbon dioxide. Okay. Next reaction with sulfite. PHITE, reaction with sulfite. Now metal sulfides react with dilute acids like HCl or H2SO4 or HLC, they form sulfur dioxide gas instead of carbon dioxide in case of carbonates. But in case of sulfite, if you take, we will get the sulfur dioxide gas. Similar type of examples or reactions can occur. Only the differences is that is in that case carbon dioxide. In case of sulfites, we will get the sulfur dioxide. So let me write the examples, few examples. 2 or 3 examples I am showing you. Suppose sodium sulfite plus dilute HCl, we get twice NaCl plus CO2 plus water. Now calcium, potassium sulfide plus sulfuric acid, we get K2SO4 plus carbon dioxide plus water. Carbon dioxide, water. Suppose calcium sulfide or magnesium sulfide, whatever you take, the similar reaction occur. Calcium sulfide in case we cannot use sulfuric acid, we have to use here dilute nitric acid or dilute HCl. I am taking here dilute HCl, so we get calcium chloride plus sulfur dioxide, SO2. In that case, we will get the sulfur dioxide. Carbonate, carbon dioxide, sulfur dioxide plus water. And here nitric acid or sulfuric acid, if you take anything, we can use it over here. We get magnesium sulfate plus sulfur dioxide plus water. So sulfides reacts with the dilute acids to evolve sulfur dioxide gas. In case of carbonate, we get carbon dioxide, but here we get the sulfur dioxide by reacting with sulfides. Okay. Next is bisulfide, reaction with bisulfides. Reaction with bisulfides, similar reactions takes place. Over there, we get sulfur dioxide and salts and water. Two examples I am giving you, not many more examples required in this case. That is sodium bisulfite. I am taking sodium bisulfite and potassium bisulfite. Now here I am taking HCl, we get NaCl plus SO2 plus water. Here we take HNO3 or H2SO4, whatever you like, you can take it, but they should be dilute. Remember, concentrated cannot be used. Potassium sulfate plus sulfur dioxide plus water. Okay, now let me say once more that bisulfides also react with dilute acids to evolve their salt, sulfur dioxide gas and water. Finally, the last, that is metal sulfide. Metal sulfide, they are also very much reactive with the acids, and they react with the acids to evolve hydrogen sulfide gas. Like sodium sulfide will produce hydrogen sulfide plus respective salts, potassium sulfide, hydrogen sulfide, the potassium salt, calcium salt plus hydrogen sulfide, and so on. So let me give one or few examples with the sulfide. Na2S, ZNS, FES, CUS, PBS. Now 2HCl, we get 2NaCl plus H2S gas plus 2HNO3, we get ZnNO3 whole twice plus H2S, H2SO4 dilute, FeSO4 plus H2S, HNO3, suppose the HCl, we get CuCl2 plus H2S, and here only HNO3 can be used, no other acids can be used, because due to the formation of insoluble coating like lead chloride or lead sulfide, so only nitric acid can be used. H2SO4 and HCl cannot be used in both the cases. Now let me conclude that metal sulfides reacts with the dilute acids to evolve hydrogen sulfide gas, H2S, etc. All hydrogen sulfide, they produce hydrogen sulfide. Only in case of lead sulfide, nitric acid can be used, no other acids can be used, because they form the insoluble coating of lead sulfate and lead chloride. So let me conclude that the properties of acids, first physical properties and chemical properties, with the metals, bases, alkalis, carbonates, bicarbonate, sulfide, bisulfide, and metal sulfide. Okay. Thank you very much. If you like, then you can share and subscribe. Thank you. Thank you very much.